Hello everyone! Today's issue is a logical continuation, firstly, of all previous releases that used such value analysis tools as the RQS diagram, and secondly, the release of the drone flyby before review 2.5 inches related to training program, professional analytics and blogging, value analysis and reviews, and unboxing. So, what unites the issues present in theoretical and practical material in the field of value analysis and mechanical engineering and a rather highly specialized training program for bloggers? Everything is simple. In both cases, the notorious expert assessment was used to determine the significance and degree of satisfaction. In my experience, fairly experienced specialists often start to fall apart at the moment when they ask the question of which method of expert assessment was carried out. In general, in order to avoid such excesses with specialists who have completed a course of study in one of the specialized training programs implemented as part of our project, today's issue was created. Thus, today we will talk about engineering methods for determining the significance, relevance, quality of implementation, and degree of satisfaction of components at three levels of abstraction using expert assessment methods. And the above-mentioned issue of the drone flyby before review WHOOP 2.5 inches, a suitable example of the structural model of the object of analysis, was considered at the drone level as a whole and the fuselage level separately. I.e., in fact, the point of this release is to show, using the example of the Jeopardy Signboard 25 drone, how the values of significance and quality of implementation used to construct the RQS diagram were determined. The classification of expert assessment methods given in the mentioned issue, a thought intended for analysis within the framework of a block review, is, in my opinion, quite detailed and universal, i.e., close in content to the standard tools of a cost engineer or analyst in any other project area within the framework of the working group. The list of techniques used in the classification will be used by us as part of today's issue in a summary table of the results of the application of engineering methods of expert assessment, and if someone is interested in a more detailed description of it, then I recommend simply reading the relevant fragment of the release of the drone flyby before review WHOOP 2.5 inches dedicated to an overview of this table. So, if we talk about the content of today's issue in more detail, then we will look at the examples of engineering expert evaluation of parameters such as the significance and the degree of satisfaction, as well as the basic parameters of the value analysis used in the diagram RQS, namely the relevance of R and the quality of implementation Q, which is derivatives. It depends on the relative values of significance and satisfaction. Of course, in this case, we are not talking about the mathematical meaning of the term derivative, but about the fact that they are used in the calculation formulas of these parameters. The calculation formulas mentioned will be given below. In particular, we will consider the standard template and algorithm for applying a combined technique based on the paired comparisons method and the association method brainstorming, the digital scale method, as well as other methods listed in the classification of methods of expert assessment of significance and satisfaction, which can quite safely be used both conditionally isolated and in a bundle. The possibility of combining separate methods for assessing the significance and the degree of satisfaction was previously mentioned by us in issue number 11, Engineering Transition, Significance Assessing Methods for Functions and Their Carriers. Such a joint application of conditional engineering methods allows us to obtain a more reliable distribution of significance and importance compared to conditional standard methods, since if in relation to the engineering association method everything can be considered relatively understandable and works according to principle, the more formulated associations of functions, the higher end accuracy. Then, in the case of engineering modification by the method of pair comparisons, everything is clear, except how exactly to compare the parameters in pairs. The comparison in pairs, as part of the application of the engineering method of paired comparisons, will be performed using the association method, With regard to the complex of expert methods and standard survey forms for assessing the level of satisfaction, the approach may be similar with the conditional logical compatibility of methods, which certainly occurs for the method of pair comparisons and the method of associations. In conclusion, I would like to note that in case of automated survey, both in the final and interim results of using methods to assess the significance and degree of satisfaction, especially in the case of a relatively small sample typical in particular for such sales models as B2B and B2G, should be evaluated taking into account the standard deviation. If we talk about the functionality of existing automated standard survey tools, the options for estimating and standard deviation, as well as the use of other mathematical or statistical tools for data processing and visualization of an analytical report, are often built-in depend on the type of software you are using. So, section 1. Assessment of the relevance and the quality of implementation for functions and their carriers. In general, this issue can be classified as theoretical materials since it includes in the practical answers, however, taking into account the fact that some of the course students have not yet had time to familiarize themselves with the content of the previous issues. I suggest returning to the several slides from the issue number 11, Engineering Transition, Significance Assessing Methods for Functions and Their Carriers. As I mentioned above, the parameters of relevance R and quality of implementation Q are calculated based on the values of significance and the degree of satisfaction. The methodology for determining which, in turn, is the object of our release today. I will not waste time on detailed commentary on the slides, given that they have already been sufficient commented on the issue number 11, noting that only the sole purpose of demonstrating them in this case is to form of understanding of why we need the values of significance and degree of satisfaction, which do not appear of the rule of analytical reports, unlike the values of relevance as the quality of implementation Q, which are the basis of the RQS diagrams. Next, we will proceed directly to the applied methods for estimating the values of the significance and the degree of satisfaction. Section 2. Assessment tools. In our case, that we not consider the standard classification of tests, which any listener can familiarize themselves with on the internet, but simplify the classification to the two conditional types of assessment tools for significance and satisfaction, differing in the degree of editing capabilities and automation, namely non-automated tools, automated tools. The second. For people who are included to formalism, we note that both of these categories belong to written blank computer non-verbal tests. Section 2.1 Non-automated tools. By non-automated tools, in this case, we mean standard forms and tabular editors usually made by researcher manually for certain needs. We will look at examples of non-automated tools a little later, since today's issue will be mainly devoted to this type of assessment tools. Section 2.2 Automated tools. Automated tools in this case mean forms in online services that are executed either using a template of using a test constructor. Within the framework of the free automated tools that I got acquainted with during the preparation of this issue, the following standard functionality is available to us. Selection of ready-made standards of top-level templates corresponding to the types of activities, for example, surveys for collecting ratings, reviews and suggestions, registration forms, quizzes and tests, or workflow forms. The second, selection of ready-made standard lower level templates corresponding to specific survey objectives, for example, course assessment survey, employee survey, customer survey, registration of event participants, and birthday invitation, etc. As for the scales used in the automated tools, at least in the free ones, I couldn't find anything supernatural, i.e., in addition to the classic choice of one of several options, this type of us is not very interested in this case, including due to the low level of accuracy. We have the Likert scale, the verbal scale, and the digital scale. And the third, formation of standard analytics in the form of diagrams of various types, circular, columnar, and etc. We will not consider the advantages and disadvantages of non-automated and automated assessment tools separately, since in my opinion they are obvious. We only note that there are no automated engineering methods for assessing the degree of satisfaction and significance in the public domain, respectively the use of available automated methods in the framework of a real project in mechanical engineering or other high-tech industry isn't correct. Section 3. Practical methods for assessing the relative value, significance and satisfaction. Section 3.1. The complex method based on the method of paired comparisons and the method of associations or brainstorming session. Applicability. Significance applicable for structural functional models, for satisfaction not applicable. Application concept. So, a general description of the method of paired comparisons and the method of associations or brainstorming has already been given in the framework of issue number 11, Engineering Transitions, Significant Assessment Methods for Function and Their Carriers. However, according to the general description, generally speaking, it's quite rare to perform a real calculation, so we will consider expert assessment methods in more detail on this issue. I suggest starting the review with the layout of the standard form of paired comparisons presented in the screen. In the upper part of the calculation form, there are text fields that briefly describe the methodology for performing a pair comparison, as well as options for performing a pair comparisons depending on the number of experts, one expert or working group, the availability of the initial data, time resources, and etc. Below the text fields is a table for processing the results of using the paired comparisons method and the basic questionnaire for paired comparison method for a group of experts. In this case, we see 5 forms for performing expert assessment by a group of 5 experts. On the right of the survey form, we see 2 types of diagrams for the 2 types of distribution of expert preference used. To the right of the diagrams is the table of expert preferences, and based on it, the diagram distribution of expert preferences based on the number of functions is constructed, which we will use when comparing pairs. The purpose of forming an expert preference table is solely to build a preference diagram and nothing more. It's incorrect to determine the significance of the expert preference table based on it in the case of real engineering calculations, because in this case you need to list all the functions in it. The case of using the paired comparisons method for structural model, or all the functions carriers in the case of using the paired comparisons method of functional model, which is often problematic, especially at early milestones for large aggregates and systems, the number of functions for which reach 10 and hundreds, and in general the benefit of using the method of paired comparisons is lost in this case. In the educational review of the signboard 25 drawn, we deviated from this rule and used expert values of relative importance formed by direct estimation without formulation of functions, as at the top level of drawn analysis. At the fuselage level, in general, this approach in unaccessible and real survive and engineering survives. In short, the distribution of expert preferences diagram, built either on the basis of the table of expert preferences or on the basis of values entered directly by the expert, as a conditional first approximation of estimating the distribution of the significance of components, and in addition it provides convenience and reduces the complexity of paired comparisons, allowing you to simply see the parameters being compared and calmly fill in the main survey form, rather than keeping them in mind. In turn, the main survey form of paired comparisons methods for the case of evaluation by one expert, and the table processing the results of application of the paired comparison methods for the case of a group expert assessment, is already a refined distribution of the significance of the components which can be used in practice. The need to perform a pair comparisons in order to more accurately determine the distribution of significance follows, among other things, from the fact that despite the similarity of the proportion between the values of significance obtained from the results of the pair comparison and the values within the framework of the distribution of expert preferences, the relative values of significance within the two approaches still differ. The option of forming a simplified or direct distribution of expert preferences based on direct input of values will be discussed below as part of the algorithm for performing paired comparisons. We only note that this option of forming the distribution of expert preferences is less preferable than the option of formulating functions and filling out the table expert preferences, at least due to the lower validity of the expert assessment and consequently a greater probability of forming of incorrect distribution and subsequent assessment of the significance of the component based on it. Nevertheless, for example, as part of a training case for a blogger, we will use the opinion or simplified or direct formulation of a preference diagram, especially since, as I mentioned in this issue, in the case of bloggers review, the audience is more interested in your expert assessment of an opinion leader, and how due to its already formed on your consequence. As a rule, no one is interested. In the case of using the pairwise comparisons method as part of product design, you should follow the recommendations for specific milestones and stages of design, engineering, documentation, development that I outlined above. Let's consider the rules for performing a comparison and the algorithm for applying the paired comparison methods by an expert. The rules of comparing values in a pair according to the VDI 2808 Part 1 standard have the following wording. First, the values 2 by 0 or 0 by 2 are indicated if according to the expert's assessment one component is more significant than other, and the values 1 by 1 are indicated if according to the expert assessment the components are equivalent. The algorithm of expert application of paired comparisons methods. Step 1. Fill the table of expert preferences into the functions corresponding to the component or function carrier and the columns using the brainstorming method. The number of functions for each component is summed up automatically and displayed in the line distribution of expert preferences based on the number of functions. Based on these values, the diagram distribution of expert preferences based on the number of functions is constructed. Generally speaking, filling out the table of expert preferences should be discussed in more detail because it just sounds like apply the method of association, formulating or brainstorming. In reality, in the process of applying this method, we are now talking about the case of formulating functions for carriers. The problem of classifying associations immediately arises, i.e., in order to formulate associations, some kind of general rule is needed, according to the results of which the associations will be comparable and equivalent, at least approximately. Thus, in this case, we are not talking about the classical brainstorming, with its main stages including problem formulation, idea generation, and the analytical stage, processing of results, which you may encounter in open sources, but about a kind of conditional format brainstorming. In addition, an important feature of classical brainstorming is the prohibition of criticism, at least of the stage of idea generation. In the case of brainstorming in relation to the value analysis, the approach is somewhat more conservative, namely, functions for components carriers should be formulated in accordance with the classification of functions in the value analysis given in issue number 7, and accordingly, when determining the significance for each component, similar categories should be used. For example, if only consumer and the technical and operational functions were formulated for one component, then only these two categories should be taken into account for other without inclusion in the list of special functions. Let me remind you that in issue number 7, in addition to the classification of functions, the rules for the formulation of functions were also considered, which also contain descriptions of a number of nuances. Brainstorming within the framework of the value analysis is usually carried out in two stages. First stage of brainstorming. The first stage of the first approximation of brainstorming involves introducing the functions already described, either in the technical assignment for the product or project milestones, or the eponymous block or the part of the technical specifications if available in the current milestone. However, the experiences show of the technical requirements or technical assignment is initially formulated on the basis of structural and functional model are described. The methodology for forming technical assignment using the value analysis methods something similar to the truth may turn out by in the technical requirements or technical assignment were formulated in the classical way as a text document. Then, as a rule, they lack a complete list of functions in accordance with the classification used in the value analysis, as a result of which the distribution of expert preferences based on the number of functions may be incorrect. To avoid such troubles, the second stage of brainstorming is carried out. The second stage of brainstorming. The purpose of the second brainstorming session as part of the formulation of functions for the table of expert preferences is to verify the data of the first stage by expanding the supplementing the list of functions that we wrote on the technical specifications, technical assignment, where formulation on the classical way as a text document. The first and second stages of brainstorming can be implemented both on one or on different milestones of the project. So, let's return to the step-by-step algorithm of using the expert method of pair comparisons. Step second. In the case of direct or simplified determination of expert preferences, values totaling 100 points are entered in the corresponding cells of the row distribution of expert preference based on the direct input of values by the expert manually. Based on these values, the diagram distribution of expert preferences based on the direct input of values is constructed. Step 3. Next, using either the diagram distribution of expert preferences based on the number of functions, preferably, or the diagram distribution of expert preference based on the direct input of values. A table of pair comparisons is filled in accordance with the following principle. In the column from the left to right, we put the importance value 2, 1, or 0 corresponding to the importance of the component in the column header relative to the components in the rows. For example, if you consider the main questionnaire of expert 1, which has filled out using the diagram distribution of expert preferences based on direct input of values, starting from the column fuselage, the logic of filling is as follows. The fuselage is less significant for expert 1 than the flight controller, in accordance with the diagram distribution of the expert preferences on the based on direct input of values. Therefore, we put the value 0 at the intersection of the cells fuselage and flight controller. The fuselage is more important to expert 1 than the engine, therefore we put the value 2 as the intersection of cells fuselage and engine, etc. for the following columns. About the green and orange cells. The orange cells are conditional diagonal or brick wall along which the analyzing objects intersect with each other. So they have a value of 1 corresponding to the equivalence. The green cells are the verification values of pairs, which are used in partially verify the correctness of the logic used by the expert. When filling out the table, i.e. after filling in, they must comply with the fill-in rule. In our case, all pairs are 2 by 0, i.e. there are no atypical pairs. If the expert misunderstood the fill-in logic or simply made a mistake, atypical pairs may appear in the green cells of different slides, in the orange cells, or on opposite sides of the brick wall diagonally, for example 0 by 0, 2 by 2, and 2 by 1. Step 4. The final distribution of the component significance based on the results data of processing from various experts, the carrier functions, is formed in the results processing table for applying the paired comparisons method. Since the method of paired comparisons can be used not only within the framework of a blogger's activities, it's worth saying a few words about the possibility of automating it, since the method of paired comparisons is usually absent in the framework of publicly available survey tools that we discussed above. So, in the case of automation of the paired comparisons method, a specialized software model for performing expert evaluation, the stage of direct pair comparisons method based on the distribution of expert preferences can be performed without the participation of a human or expert. The stages of function formulating brainstorming can also be automated, but not completely, i.e. even in the case of automatic formulation of functions using AI, there is still a need of verification of the obtained formulations by an expert, i.e. full automation of the method of paired comparisons, in my opinion, is unlikely. The stage of direct entry of points into the cells of the column distribution of expert preferences based on direct input of values, in my opinion, can hardly be automated due to the high uncertainty in the formulation of the question. The example described above of using a complex method based on the method of paired comparisons and the method of association, the brainstorm method is performed for the elements of the structural model, i.e. the component of carrier of functions. For functional model elements, i.e. functions, this method is also applicable, with the only difference that instead of the term component carriers of the function in this form, it will be necessary to use the term function, i.e. for example, as part of filling out the table of expert preferences, we do not formulate functions, but list conditional ANDs. Involved media, i.e. components of functions carrier involved in the implementation of the functions in question. Section 3.2 Standard Digital Scale Survey Method. Applicability. First, for significance, not applicable. Second, for satisfaction, applicable only for structural model. Not applicable for functional model due to the fact that the function is an idealized concept to which certain characteristics such as reliability on the function, transportation, storage, and etc. are not applicable in accordance with the column of evaluation criteria. I believe that the most attentive and truthful listeners immediately had a question in connection with an illogical at first glance statement about the inapplicability in the standard of questionnaire methods with a digital scale for determining significance. Indeed, what could be more logical than, for example, to evaluate the significance of a component on a scale from 1 to 10 or from 1 to 20, and then find its weight on the total number of points using the promotion method. But the problem lies in the fact that even if we can justify each assignment score, this issue is discussed below, it's in process of substantiation, namely the formulation of criteria for justification, that we will face the problem of equivalence and mandatory criteria. For example, we have chosen a rating scale from 1 to 10 and the condition for obtaining one option to meet one criterion, i.e. then will also be 10 criteria. Let's try to formulate criteria, for example, for a designer. For me, this is easiest option because by education I am a design engineer in aircraft construction. The first thing that came to my mind was look to that list of titles of the technical assignment sections according to the GOST 15 or 16 and try to formulate something based on it. According to the results of the analysis of this standard, which is generally used by all developers working in accordance with the United System of Design documentation, the only purely design engineering criterion turned out to be the criterion of compliance with technical requirements for units and systems, as we can see from the table shown on the screen. So, the results of forming a list of criteria gives us a comprehensive picture of the criteria for evaluating product components, which includes such areas as marketing, design engineering, certification, reliability, industrial design, and so on. At first glance, it turned out well, but the problem is that these criteria do not make it possible to access the significance of some components relative to others, since they are conditionally universal. For example, the fuselage component scored from 1 out of 8 out of 8 points. Each expert assigned 1 in the range from 0 to 1. And the power plant scored 5 points at the same milestone. Then, generally speaking, this doesn't give anything in terms of the significance of their relative to the second. However, from the point of view of the degree of satisfaction is somewhat different. Given that we're talking about a milestone in a prep project or product design documentation, it's quite logical to assume the current flexibility or volatility of such a characteristic as degree of satisfaction. In other words, if the unit of system is under active development, they can obviously change their status from the non-compliance with the technical requirements to aggregates and systems. Individual experts put 0 on the scale from 0 to 1. For compliance with the requirements of the design engineer, all experts put points other than 0, and increased points compared to the discrepancy. Accordingly, without fails, modestly, it can be argued that the proposed list of criteria fully correspond to the concept of the degree of satisfaction, P with the product of its component, which means that it allows us to calculate the value of the quality of performance, the quality of implementation, use the construction of the AQS diagrams. Regarding to the GOST 15 or 16 standard, on the basis of which the columns responsible direction and formulation of evaluation criteria of the table are filled in, it would like to note that, for example, nominal and marketing section have somewhat intricate names. It name and scope, basis for development, purpose and purpose for development. The section on industrial design engineering and ergonomics is less intricately called aesthetic and ergonomic requirements and requirements for materials used. I have already mentioned the wretches of actually filling the economic indicators sections, which takes place in practice in issue number 10 of our training course, and a variant of its alternative extended filling was given in case number 2. In my opinion, this approach, generally speaking, is a reflection of the attitude of the domestic design engineering school in some industries. For example, to marketing, design engineering, and economics, yes, I'll give them 1 point each to the lag behind and more, in particular to aerospace industry and the automotive industry. Although by second, this applies to the lesser extent, since the feedback mechanism is more developed and the competition is tougher. The actual content of these sections of technical assignments is negligible in practice, which is reflected in its volume and content. The volume is a maximum from 0.1 to 1.5 pages. The content is dry general phrases without any quantitative and qualitative characteristics of analysis of designed product. Listeners may object and say that all the mentioned sections are presented in relative detail on the business plan, but the trouble is that for most heads of lower-level design engineering departments, the business plan belongs to the category of inaccessible information. For example, as a design engineer in the aerospace industry, I have never come across either a business plan or a mention of any decision-making criteria other than technical answers. A similar approach has already been developed at the university, i.e., as a rule, there are no questions about the economic part of the graduate work of the design engineer student during the defense, and many scientific supervisors, generally speaking, do not even know about the mechanism for synchronizing the results of graduate work with marketing, industrial design, and quality management, and therefore do not put forward any requirements. On the other hand, the situation is similar. If you ask a marketing student about the connection between his work and industrial design, he will most likely look at you as a patient. Industrial design student isn't so bad in this case because firstly, there are a number of the disciplines similar to design engineering disciplines, and secondly, industrial design, and I'm more or less familiar with this content of the stage of transition from industrial design to design engineering documentation. We are talking about the preparation of a set of design and documentation to ensure industrial design documentation to ensure the selection of technology and materials. Application concept. Let us consider additional nuances of the formulation of criteria for assessing the degree of satisfaction related to the conditional engineering and non-engineering of individual characteristics of method under consideration. Firstly, with the fact that when performance surveys, the results of which will be used in the engineering calculations, the variable scale and the Likert scale are not used. Those who do not what these scales can easily find out in open sources, which are presented as almost all standard automated survey tools which we reviewed at the beginning of the issue. These two types of scales, unlike standard surveys performed within the framework of standard quality management and marketing tools, usually contain 5 or 6 options for indicating the degree of significance or satisfaction, depending on the type of study, which doesn't provide the accuracy or flexible of assessment necessary for the case of engineering calculation. Thus, the minimum scale value is 10 and the maximum is 20. Secondly, in the case of a conditional non-engineering survey, we could be satisfied that the respondent would simply choose a number from 1 to 10 or from 1 to 20. However, in our case, we are considering a conditional engineering survey, and therefore either assigned or not assigned one of the 10 or to 20 points is possible only if it meets a certain criterion. The screen shows an example of scoring criteria for a 10 or point scale. Thirdly, standard surveys are designed for the average respondent whose professional field of activity, in most cases, generally speaking, is little interested to anyone. At most one of the questions will have an option to choose a professional field, which the rest of the questions, as I have already said, will be universal. In our case, we determine the significance and degree of satisfaction within the framework of the work of a working group consisting of specialists of various profiles, i.e. we are dealing with a case close to the B2B rather than B2C format, and if within the framework of method of paired comparisons the difference in profile level of our professional knowledge is correlated by the fact that when filling out the table of expert preferences, the expert independently formulates functions, his own design engineer, his own industrial design engineer, his own marketer, on the basis of which the distribution of expert preferences is then formed, then in the case of criteria for assigning points according to the questionnaire. However, there is no such universalism. Thus, the disadvantages of the engineering questionnaire method with a numerical scale is that it is necessary to create a special scale for each professional profile. Here, I would draw a parallel with the issue number 7, in which we consider the standard and the conditional universal classification of functions, which I tried to form so that I meet the requirements of the main members of the working group, i.e. its rules, albeit roughly new design engineering, industrial design, and marketing components, since it mentions the basic concepts of these 3 professional fields. Of course, this classification is not a dogma, since, for example, in the classical value analysis, the classification is different. Its advantages, its disadvantages were also discussed in issue number 7. In fact, the classification given in issue number 7 is also good because it can be simplified by discarding certain types of functions for isolated use. For example, only by a marketer who is not particularly interested, especially in early stages, in technical and operational functions. Fourthly, even after the formation of specialized evaluation criteria for the forementioned areas of activity, we must take into account such factors as A. the degree of abstraction of consideration, and B. the milestones of the project in the context of the availability of initial data for decision making. With regard to the degree of abstraction of the review, I think everything is relatively clear, and therefore I suggest that the table presented on the screen we do not deviate from the concept of free layers abstraction, which we have already used in issue number 10, devoted to the analog of the approaches of the value analysis and approaches to the formation of technical assignment in accordance with the GOST 15016, and which is like it seems quite sufficient to the design engineer. We are talking about the following three levels of abstraction or detail. First, the upper level abstraction, the product level at which we operate the main aggregates and systems. The second, the average level of abstraction, or the level of the main aggregates and systems for which individual technical assignment is formed. And the third, the lower level abstraction, the level of small assembly units or individual parts for which a separate technical specification isn't formed. Regarding the milestones of the project, everything is also quite expected, taking into account the fact that our field of interest includes only the pre-project and milestones of the project design engineering documentation, technical proposal, preliminary design, and technical project design. They are indicated in the table of criteria for assigning points for the digital scale. In this table, I have already mentioned universal digital scales are presented with a different list of criteria depending on the level of abstraction of consideration used at various milestones of the project to determine the end-to-end satisfaction index P for function carriers and subsequent constructions of the end-to-end RQS diagram. At first glance, viewers may ask the question, why should a marketer or industrial designer consider the lower level of abstraction? I.e., in fact, we are talking about the level of details and relatively simple assembly units. My answer is that there are cases when a marketer needs it. Here's a simple example from my practice and the period of work of the automotive industry, which I often mentioned in the previous issue, but in a different context. During the meeting of the working group, questions arose about changing the cost of injection molding tooling for the fuel filter cap bracket. Benchmarking showed that all manufacturers have this part with an embossed surface, i.e. specially made roughness, which doesn't leave streaks and fingerprints on this detail. The design engineering department looks at position on the basis of benchmarking. The direction of cost engineering took the position for discrepancy between the effect of introducing an embossed surface part into the design engineering documentation, and increasing the price of production tooling. Final decision was made with the involvement of marketing and industrial design and quality management departments, and embossing was introduced in the bracket design documentation. Nevertheless, certification and operational criteria, as well as the reliability criteria, are excluded for the lower level abstraction and the end-to-end or upper level scale, since the analysis according to this criteria is carried out at the level of parts and simple assembly units, but the level of systems and aggregates, the number of criteria has been reduced from 15 to 10 in this table. Regarding to the need to form local scales for design engineer, industrial engineer, and the marketer's questions is, firstly, is how to exactly these local scales can be used, i.e. for purpose of their formation, and secondly, in the list of criteria used, regarding the purpose of the formation. The simplest definition would be clarifying the methodology of expert assessment of the degree of satisfaction for the areas of marketing, industrial design, and engineering. In particular, the results of such an expert assessment can be used in the initial internal local work reporting on the direction design engineering, industrial design, marketing, and in external reporting, reporting with the working group, i.e. the process of assigning the value from 0 to 1 when determining the end-to-end satisfaction indicator, namely the filling out the table shown on the screen. For example, the simplest but less accurate method of assigning satisfaction values from 0 to 1 is satisfaction or dissatisfaction with local criteria, for example, for standardizations. It will be complied with the requirements of 5 out of 10 GOS standards for the product being developed, and the corresponding factor is 0.5. For a design engineer or industrial engineer, this can also be expressed in the format of a quantitative assessment, i.e., if all requirements are met for 7 out of 10 relatively equivalent components of the fuselage, we can put a coefficient of 0.7 and etc. A more accurate approach to assigning a satisfaction value from 0 to 1 is to use the local scale mentioned above, and here return the issue of the list of local criteria used within the framework of which I propose to follow the path of unification and use. For example, for the professionally closest to me design engineering and technology area, the list already knows to us the criteria shown in the table of the factor research method, which is presented in the example of local digital scale for the drone fuselage. In terms of the formulation used in the classic method of factor research, in my opinion, there is no point in changing them, i.e. the term unification in this case means nothing more than using the same analysis data both within the framework of the application of method factor research or MFR and within the framework of determining the level of satisfaction at the local level, within the only difference being that within the framework of the classical MFR we put either 1 or 0. In the standard form and as part of determining the level of satisfaction at the local level, we put values from 0 to 1, i.e. in fact, if the question are the functionality unnecessary elements, carriers of functions, and can they be eliminated. We put 1 in the range from 0 to 1, then there are no unnecessary elements of one component out of 10 components of an assembly unit can be excluded. Then we put the values 0.9, etc. if the answer to the questions is it possible to apply fundamentally different technical solutions based on different power squared of a different physical principle. Is there are two equivalent solutions, the current one and one alternative. Then we set the satisfaction value to 0.5 and etc. Then the overall satisfaction value of component carrier at the local level, see the pink cell, is transferred to a high level, i.e. to the level of the end-to-end satisfaction scale or product level, which was considered in the little higher. For example, if according to the design engineering and the technological criteria of the end-to-end scale we had values of 0.9 and 0.2 respectively, with the maximum possible value of 1 plus 1 equal to 2, then the overall satisfaction for these two factors is equal to 0.9 plus 0.2 by 2 is equal to 0.55. Accordingly, the total value of the degree of satisfaction with the component carrier calculated at the local scale, at local level, should be equal to 0.55, which we have the table of the screen, see the pink cell. The issue of distributing the calculated satisfaction value between the two types of criteria, design engineering and technological, of the end-to-end scale, is solved individually for each product, depending of the type of component.
The answer to the question why, if there are two need, create scales for the cost engineer, the project manager and the buyer. I suppose no one has, but if they do, I'll explain this. The salaries of three of the specialists of the working group, in according terms, relate to overhead costs, or rather administrative costs, in the sense that, unlike a marketer, design engineer and industrial engineer, they do not produce conditional factual material that can be attributed to intangible assets and recorded on the balance sheet. In general, according to the results of consideration of two basic methods of engineering assessment of the relative values of significance and satisfaction, individual listeners may feel unnecessarily cumbersome, unnecessarily complicated and laborious compared with the classical method of pair comparisons and the method of digital scales. And indeed, what could be easier than to put down digital values within the selected digital scale by eye or from the lantern, based on his extensive life and design engineering experience. In general, regarding what should sometimes be done with a rich life experience, I recommend turning to the novel The Life of Insects by Victor Plevin, and regarding to the desire for simplicity, to the famous character Bulgakov, who suggested simply taking everything and sharing. Generally speaking, it's quite difficult to overestimate the role of the stage of determining the significance and degree of satisfaction within the framework of design-to-cost methodology and the economics of the project as a whole. To begin with the amount of targeted direct costs for product components in the early stages of the project is determined based on this allocation. An indirect need for engineering distribution of importance often arises in parallel direct products development organizational processes, such as determining the degree of localization of product, assessing the complexity of R&D, and etc. I plan to form the missing local digital skills for the industrial design engineer, marketer, and technologist with a format of scientific publication carried out jointly with students the discipline design to cost management methodology based on the value analysis, the start of lecturing of which, under my leadership, is scheduled for the fall of 2025 at the Department of Industrial Management of MISIS. And at the moment, a working program of the discipline has already been developed to the first approximation of methodological guidelines for the coursework, which will implement the concept of developing a high-tech product within the framework of a game working group consisting of students, and all of this accordance with the design-to-cost management concept. Let's return to the table of expert assessment methods, partly adjusted to the required parameters column based on the results of practical study of the issue of using these methods. In particular, the standard survey method questionnaire method was renamed digital scale survey or standard survey, and only satisfaction is attributed to the required parameters of this method. For the complex method based on paired comparisons method and the association method or brainstorming, the possibility of determining satisfaction is excluded in accordance with the conclusions we received on today's issue. The possibility of determining the significance has been added to the list of required parameters, or, in other words, to the functionality of the method of comparing mass-dimensional characteristics and the method for comparing combined technical and economic parameters. Otherwise, the table remained unchanged, except for minor formulations of possible conclusions based on the results of the application of the listed methods of expert assessment. In terms of expert assessment methods, starting with the method for comparing mass and dimensional characteristics to the methods for evaluating the quality characteristics of residential buildings, we will not consider the detailed mechanism of their application, but simply put down hypothetical random values to demonstrate the general logic of the calculation, since it either quite banal and understandable from the description of the method, or it not applicable in our case due to the lack of initial data and the low level of accuracy of the estimate, namely for the method of comparing mass dimensional characteristics and the method of comparing combined technical and economic parameters. The larger the component in size or weight, in more significance it is for the latter, taking into account the cost of a kilogram, square meter, square inch, and etc. units of product measurement. For methods 6 through 12, no detailed description is provided in this case for the reasons mentioned above. Let's go back to the summary table steps for the drone and fuselage, and let's consider the list of final analytics value formed based on the results of the application of expert assessment methods. See the green cells with the names of analytical assessment tools. In general, all of these tools are typical for analyzing the results of survey or other forms of research. Let's look at these tools for interpreting analysis results a little more detail. Regarding the calculation of the arithmetic mean, maximum, and minimum scores, as well as the median value, I believe no comments are required. In terms of the standard deviation, we can
assume that individual specialists also know the applied methods of its application, but I will nevertheless focus on it in a little more detail. In fact, the standard deviation is a tool that allows you to discard obviously incorrect estimates. For example, if most experts have set the significance value to order 5 and some have set it to order 2, then knowing that the value of the standard deviation is 0.15, we can say that order 2 can be attributed to obviously incorrect values. Since this value doesn't not lie, the range from 0.35 to 0.65, accordingly, after discarding this value, the standard deviation is adjusted and a decision is made either to discard the following values or to complete the process of correcting the analysis results using the standard deviation value and generate an analytical report. In general, the case considered isn't typical, since we are dealing with data obtained from the results of an investment or of an assessment by one conditional expert. This may not be an expert, by an example for a division of expert, but by all possible methods in practice, the situation is reserved, or rather, it depends on the milestone. In the pre-project, in general, not the most accurate of the listed methods can be used, all except complex and questionnaire using a digital scale, but at the same time, at least time-consuming. Upon completion of the pre-project, at the start of the technical proposal milestone, there is a need for more accurate analysis, and the advantage should be given to the first two methods, complex and questionnaire using a digital scale, subjects to an increase in the sample. In fact, in practice, for example, the technical proposal milestones, such a table, is likely to look somewhat simpler in terms of number of expert assessment methods used, but more complicated in terms of the volume of experts involved. For example, for the case of determining significance and satisfaction by a group of 5 experts.
In conclusion, I would like to refocus on individual phases of the practical application of methods for assessing significance and satisfaction within the framework of the value analysis and solving engineering problems, namely, firstly, engineering methods for assessing significance and satisfaction are more complex and time-consuming than the standard surveys for significance and satisfaction that we encountered in everyday life, based on the results of shopping, service provision, etc. And secondly, the basic methods for determining significance and satisfaction are an integrated method, the method of paired comparisons used in tandem with the formulation of association by brainstorming, and survey using a digital scale respectively. Thirdly, the determination of the degree of satisfaction is a complex process, the results of which depends on 3 basic factors. First, the level of abstraction of the review and the corresponding list of specialists involved satisfaction assessment profiles. Second, project milestones. The third, the list of satisfaction assessment criteria used. In our case, we used an end-to-end upper-level list of criteria based on the technical assignment structure, as well as a local conditional design engineering list based on the list of criteria from the standard forms of method factor research. And fourthly, the correctness of the results of the assessment of significance and satisfaction, if not the key, then one of the key criteria for evaluating the correctness of AQS diagram, which in turn refers to the basic tools of both the classical value analysis and the design to cost management methodology created on its basis. That's all for today. All bye.